Alright, time for another draftphysics.com, debatephysics.com also, but still struggling to find anyone to actually have a debate with, who's honest and, shows just a little bit of integrity. Frankly, in a conversation, ask them a simple question, they give you a simple answer. So we'll go over some questions and answers that was part of my interaction with Paul Nord, which appears to have finally come to a conclusion. And it was really pointless because he's impervious to being educated. Okay, it's just, he won't accept any new information. He won't watch a video, won't listen to an argument, won't pay attention to an argument, just keeps reciting from his Bible. So it's like talking to a religious kook. And that's exactly what they are. So this is a science teacher, and this is what I found with all these science teachers. Physicist Michael, this guy, Bruce Yerney, the last guy I did a video to. All science teachers all fail to stay on the subject and make a point of, making an argument and showing that to be true with some sort of reasoning and evidence, and they just won't do it. So this started with Steve Mould's lever video, where he contended that the law of the lever is actually a big mistake. There is no law of the lever. Levers don't conserve momentum. They don't just provide an interpreting device for exchanging energy, changing heavy, slow things into fast, light things. They don't do that. Instead, they do conserve kinetic energy. So where you would have the expectation that you put a 2 mass in with 1 velocity, you have the expectation you get a 1 mass out with 2 velocity. They say it's only a 0.4 increase. So you lose 30% of the momentum, which in the classical physics is the thing you must conserve. You can't just throw it away. And clearly the inverse would mean free energy, in the sense that their argument is apparently that if I put a 1 mass going 1.4 velocity in one side of the lever, I can get a 2 mass going 1 velocity out the other side, which would be free momentum. So, that's where it started. That's what I was hoping to resolve, because this is such easily proven science, and they first won't concede that it should have been done, these experiments. The proof should already be well available, and they won't even concede that part of the argument, which is just disgraceful. They're just terrible human beings. And they can't do anything honest. They can't have an honest conversation. So, with that preface, let's go to the questions I did ask in the middle of the conversation. So, hundreds of emails. Again, me making arguments, explaining how springs work, different things, why different experiments aren't fair, and he would hear none of it. So he says, I'll offer some comments to your questions, but if we're not agreed on terminology. So again, he thinks this is about terminology, when the word momentum has a clear definition, the word kinetic energy in the sense of the kinetic energy theory and the formula has a clear definition. And the simple argument is any time you exchange energy between unequal masses, you have to destroy one and conserve the other. There's no options, or destroy both. But obviously I would argue you never destroy momentum, so it's always a sure bet. But he can't, he can't deal with the actual subject. And he didn't even watch the Steve Mould video, which is the irony, because he thought Steve Mould was arguing for the conservation of momentum and obedience to the law of the lever, because he didn't watch the second half of the video where Steve Mould points out that no, you don't conserve momentum and the law of the lever doesn't mean anything. Archimedes was wrong. But they won't say those words. It's what they believe, it's what they're arguing, but they won't say the exact words. All right, so he says there's not much we can accomplish. So again, the questions are really direct, get right to the point, and he evaded every single one. So we'll go through them and I will explain. All right, consistent with the law of the lever, do you believe levers conserve momentum? Not a difficult question. Half mass is twice the distance, move twice as fast. That's conservation of momentum, and that's the law of the lever. And so he says, depending on how you describe the lever problem. So there's no description, there's just a simple argument. What will you get on the other side? And he won't answer the question. The lever generally exerts an external force. So again, they're pretending there's some external force and that somehow the fulcrum or something else is somehow doing some action. And that wouldn't explain where you lose momentum. So that's not even close to an explanation. So you might take some care in applying the conservation of momentum laws. There's no care needed. And it's a simple question. So he's saying, basically he is saying yes, he does not think a lever conserves momentum, and the law of the lever was a mistake. That for thousands of years, human beings believed that levers conserve momentum, that they do produce this conversion. They are a conversion tool, big M, little v, into big V, little m. And they're saying it doesn't happen, even though there's literally thousands of years of experience of it does work. So anyway, it's been shown that it works as a balance, that clearly a one mass moving twice the velocity does balance with a two mass moving one velocity. It's clear they do balance, and the only argument is if they were released from that motion, that connection to the lever, that somehow they wouldn't retain those velocities, and of course they would. All right, we discussed a freely spinning rod. So okay, yeah, we did, and another point where momentum is conserved. Momentum was conserved in that case. So again, it doesn't make much sense that they're saying that somehow this doesn't conserve momentum, but spinning does, when it's the same difference. And obviously other people are arguing that the spinning case doesn't work at all either. Anyway, so he says Steve's mistake at about 5-minute mark in his video. So we know that Steve's video, at the 5-minute mark, he was setting up the wrong premise. He was explaining what intuition would imply. He's calling it intuition. And later in the video, he states exactly the opposite argument. Was exactly that. So he didn't watch the video. The answer is no. The two objects will experience the same acceleration in Steve's example. The answer is no. The two objects will experience the same acceleration in Steve's example. No, they won't. I mean, obviously one's being accelerated twice the velocity, so it's got the same acceleration. You can't go twice the speed if you're accelerated at one velocity. You can't go two velocities, so that doesn't even make any sense. But to move twice the distance, it's a lever, so you don't have any choice. As described in Steve's problem, it will take longer. So again, he's arguing that somehow it's going to put up a huge amount of resistance. The lighter mass is going to somehow resist being moved, and somehow is going to be heavier than what it measures on a force meter. You can't get the force meter to feel it making any more weight. So it's all just bullshit. There's no facts here. He's just stating his catechism crap, and you're just supposed to repeat it. Let's see. Take longer with the same acceleration. F equals ma. So we know it's F equals ma doesn't have anything to do with it, and it's obviously not the same acceleration. It's a half mass, and it's accelerated at twice the rate. So it's So we'll draw it, just because we'll draw every one of these, just to go over it again, all right, and again, and again, and again, and again, just pointing out there's absolutely no response, no rational response to any of these arguments, no debunking of the arguments, nothing. And so it's just, these are just absolute facts. So again, I did the simple case on my porch of one mass, four distances, and a four mass, okay, from a lever hung from above. A very nice balance, okay. So four mass, versus a 1 mass at 4 distances. Okay. Balances perfectly. So whatever energy you put in, it'll oscillate 100 times, demonstrating that yes, the 1 mass will go 4 times the velocity of the 4 mass. And those two things will be the same weight as far as gravity is concerned, and it'll eventually just stop and be perfectly balanced. And it's very easily unbalanced, so it should just be understood that all you have to do is put a little tiny bit of extra weight on one of them and it'll show that they're not balanced. So it's pretty much saying that any motion created will be the same amount of energy on both sides of that oscillator, because it will oscillate perfectly. All right, now both I and Brozo did the experiment where you use a constant force, okay, on a lever, and you just launch the 2 mass and the 1 mass at twice the distance. And yeah, I didn't have the equipment for measuring velocities, but what I clearly showed in the video was this was going a lot more than 0.4 faster. Okay, yeah, it was a lot more than 0.4. Looked just like twice the velocity, frankly. Dramatically different velocity, you know. And the reason, the logic simply is that for the lever to do these two motions, moving this at 1 velocity and moving this at 2 v, the lever itself moves exactly the same, and the spring moves exactly the same. So you know you're getting the same energy into both experiments. So it's a very good test. Now when Brozo did it, he got a frame rate of 19 for the slow object and 11 for the fast one. Not even close to 0.4 faster. Okay, so you know, more evidence. Now what we need is this, the whole request is that somebody should do these experiments in a nice clinical environment, slow motion camera, get really good results, and therefore there's no longer any dispute about which one is conserved, kinetic energy or momentum. But clearly the law of the lever is just this simple argument that you just count the distance, and the distance is exactly correlates to the velocity. So twice the distance is twice the velocity. This part of the lever moves twice as much as this part does for any action on the other side of the lever. And the simple argument also is that these two things weigh the same. If you push on this side, these two objects are going to weigh the same. A force meter will say they have the same, it's the same pressure to move them. Just a fact. And it works for gears, and so he talked about a rotating stick, or it could be a rotating disc, and if I put the 1 mass 2 distances and I put the 2 mass 1 distance, you know, the fact is that as a spinning object it'll be exactly the same. I'm adding the same amount of extra burden to the spinning wheel if I put the 2 mass here or the 1 mass out here. They'll equal the same thing because you're moving the same. You're moving half the mass at twice the velocity. You have the same mv you've added to the motion of the disk. So clearly not a complicated argument. Let's see if there's anything else on. So so it covers all. Something spins just fine with the 1 mass and the 2 mass. It's nice and perfectly balanced. It's balanced this way, and it'll also be balanced in terms of its motion. If you give it motion, it's not going to process or do anything wacky, because those two things, the 2 mass going 1v and the half mass going 2v, is exactly the 1 mass going 2v. It's the same thing. Alright, so just to be clear, his basic answer is that he agrees with Steve Mould, even though he thinks he disagrees with him, that if you put a 2 mass going 1v into 1 unit of distance from one side of the lever, that you won't produce a 1 mass going 2v, you'll produce a 1 mass going 1.4v, because it does take more energy, okay, because this would have more kinetic energy. A one mass going 2v would have twice the kinetic energy. So if it was 2x, I should have put 2x the kinetic energy if it was going 2v. And so you'll be making free kinetic energy. So they can't allow that to happen. So to fix it, they decide to just destroy 30% of the momentum and pretend it doesn't create the same problem in reverse. So their argument is that a one mass going 1.4 dropped on this part of the lever will create a two mass going one velocity coming off this side, meaning they created twice the momentum. So that's their argument, and it's pretty silly, frankly. It's not a good argument. Yeah, it's really bad, and people should be accountable for making bad science arguments. Bad science arguments shouldn't endure and win. They should fade and die, and it's just part of this tragedy that the defenders of science don't really care about the quality of the science. They just care about that the religion is likable. They want a story that's fun. They don't want the truth, is a simple answer. Just like religious people, they can't handle the truth. All right. So, question 2. Do you believe pulley systems conserve momentum? So that came up in Steve Mould's video where the Minute Physics guy put a little clip in basically arguing that pulleys do conserve momentum. I mean, there was nothing in his argument or in his math or in his demonstration that showed anything else to be true. But somehow he's implying that somehow yes, and they don't conserve momentum when everything in his argument pointed to the fact that, yes, of course, the momentum is conserved. Everything in the image, everything stated as the math, all pointed to the conservation of momentum. He didn't show how the 1.4 thing happens at all. All right, so he says, again, there's an external force. So, you're basically just saying, okay, the external force is it's connected to an Earth somewhere or some reflective surface, but that's all it is. There's no loss of energy through that mechanism. So anyway, the total momentum may be conserved. So it either is or isn't. So what does this even mean? It may be conserved. Again, just such a bullshit statement. You're saying, what does the pulley do? Do they convert the big M and little v into the big V and the little m or not? And they just keep evading the simple question. But not the vector quantity. So he says the total momentum may be conserved, but not the vector quantity. How does that make any sense? Momentum's supposed to be a vector. So how the fuck? How can you? It doesn't make any sense. So consider a perfectly elastic ball bounce. So he won't consider that because this is where I explained to him how bouncing works, and that every elastic device collects energy very well. It has a problem giving it back because when it gives it back, there's a point where the object it's pushing leaves the surface of the thing doing the pushing, and the thing doing the pushing isn't finished pushing yet. It's just a fact. It still has more energy left in it that it can't give to the object because the object already left. It already broke contact. All right, the momentum may have the same value after the bounce, but its direction will be different. So again, we already know that levers perfectly exchange direction. Nobody argues that the two mass, going back to the drawing, that the two mass somehow doesn't, you can't do that perfect experiment where you just put a two mass in this side, you put a two mass sitting there on the other side, and you'll get whatever 95% of your momentum will be conserved and your kinetic energy because the mass is the same. And so no matter what you think is real energy, momentum or kinetic energy, either one will be conserved, and it says it's substantially conserved, except you'll switch the direction. So obviously direction doesn't mean anything. Nature can change directions without sacrificing something's energy. Just a fact. So, arguing that there's a plus direction and a minus direction and that the direction has to be conserved would be idiotic in light of the very function of a lever or a spring. A spring does the same thing. It reverses the direction. So, they have this perception that when you compress a spring, you put twice the energy into the thing you compress the spring against, which there's no evidence for. Because all you did was reflect it off of that surface. If you don't reflect it, if you actually absorb it, you're not going to get all the bounce. So if the other surface actually does move, you can't have any expectation to get your energy back. You only get your energy back because there's a perfect reflection. All right. So next, won't bother drawing pulleys. So just for the record, 2 simple questions, 2 complete evasions. All right. Question 3. Do you believe that rocket thrust can give a rocket more energy than the momentum of the thrust? So I suppose I needed to reword this because, again, it's just going to cheat the simple argument. You can measure thrust based on it's always going to be made out of some kind of particulates. And you can measure the speed of the particulates, the mass and the speed, and then all you're doing in the case of kinetic energy is you're squaring the velocity. So it's always the same input data, and the simple argument is I can get 2 numbers. I can measure the momentum of the thrust and get a number. I can measure the kinetic energy and get a number. Which number will the spaceship get as a equal and opposite reaction? And the simple truth is it's always going to be the momentum, and kinetic energy will be a useless number because it won't have anything to do with how the spaceship moves. So he said to that, you were asking me to compare momentum and energy. Yeah, they're 2 distinctly real things, okay? For thousands of years there was just momentum. Nobody believed in any other quantity existing. They didn't see it, and so they never said it existed. And then, Huygens and Leibniz invented this nonsense. And for whatever reason, over the next 100 years, bad scientists decided the garbage theory was the truth, even though there was no physical evidence supporting it, even though it violated things like the law of the lever. Elemental things like the law of the lever. All right, the question makes no sense. So, what do you mean it makes no sense? It's clear that the thrust has those 2 properties. And he refuses to acknowledge that those are 2 different numbers. It doesn't. So anyway, he says you might as well ask: can density of glass of water change its mass? What's this? These are 2 different ways of describing properties of a thing. So what a complete evasion. So clearly, I needed to rewrite that question in some way. I guess with more words, because they're scientists. You have to explain it all to them, I guess. It's pretty simple. Do you believe that rocket thrust can give a rocket more energy than momentum of the thrust? Do you believe that rocket thrust can give a rocket more energy than the momentum of the thrust? So all you have is the momentum of the thrust, the mv. That's the only thing you can measure. You can't measure the mv squared. You can only measure the mv. And so yeah, I guess it needed to be stated more clearly that there's 2 calculatable numbers for the value of the fuel. And it's as simple as me just throwing something. If I'm in space and I release some mass at a velocity, that will be energy, in the sense that will move me in space. And the little stuff that shoots out is the same thing as the big stuff. You're just saying what quantity of motion does it have, and that's all that's going to decide. So it's clear that momentum is the only one obedient to the 3rd law, and that's what the rocket proves. So I guess we should draw some rocket just for the hell of it, just to emphasize again the point that this is This is sort of, I mean, you can only call it decisive evidence. It's, it's so clean and clear. And, for people to argue, it, it just seems so pathetic. Alright, so this is the simple as you can get. You just got something in space and you're going to move it. Okay, so, and even for lifting off, you can argue, okay, you have thrust, and thrust is just made out of a bunch of stuff moving a velocity. And the fact is that you could measure a millisecond of its force, and you could say it's 2,000 joules of kinetic energy, mv squared, and it's only 2 joules of momentum. So if you just measure the momentum. So you have the same example with a bullet and a gun. The bullet has 2,000 joules, even though they're supposed to be an equal and opposite reaction. The gun only has 2. Just a fact. But the fact is no matter which one, the only one that's going to be conserved, that is the only one that's going to make the spaceship move, is the 2 joules. The 2 joules of the gun recoil, the 2 joules of the bullet's momentum. Okay, and the only thing that's going to move the spaceship ever is an exchange of momentum. And this sort of relates to the ballistic pendulum also, but I'll keep the argument separate. So there's no way for this to absorb it. I mean, if I shoot the recoiling gun, if I throw a 1,000 atoms, okay, at 1 mile an hour, it's going to be the same as throwing 1 atom 1,000 miles an hour. It's going to be exactly the same work internally. It's going to take the same capacity, and the ship is going to move exactly the same. So it just doesn't matter. This kinetic energy number is meaningless, and the only number that's going to matter is the momentum number. The momentum is the only thing that gets an equal and opposite reaction, and it's the only thing that does work on the spaceship. So they keep talking about this kinetic energy thing having something to do with doing work, but it can't do any work. It doesn't do it. There's no evidence it does it. There's no example where it actually does this extra amount of work. That something spinning 5 times as fast does 25 times the work. There's no example. And there's clear, this the simplest thing you can get. The simplest thing, you're in space sitting there and you want to move. And so you know this kinetic energy theory, but the kinetic energy theory won't get you any more work. Because the only thing that's going to get you moving is an exchange of momentum. You have to give away, okay? Basically, the argument's simple. The simple argument is everything has stuff in it going both ways. And basically, if you give away stuff going this way, that is, I throw a piece of matter away, the only way I could throw it away is now I'm giving away something I had, a property I had. I had matter going this way inside of me. And now if I give away matter going that way, I still have matter going this way because I was balanced, and now I'm not going to be balanced anymore. So whatever the relative balance is, you've broken the relative balance. If a piece of you flies off with a velocity, you just gave away your balance. And so you just have the opposite. So there's no need for a second law, a third law in the sense of some equal reaction happens. It just means that if you have $10 and you give away 5, you only have $5. And if we're talking about direction, and you have 5 bits of direction this way and 5 this way, and you're staying in one place because you have an equal amount, and then you give away the 5 going this way, well, obviously, you're going to go that way. So it's really simple mechanics. This is the root of the function of the universe, and they don't have the right answer. They're getting a very wrong. Like I said, they wouldn't land on the moon with kinetic energy. It won't work because it won't do work. It won't move lunar modules. It won't navigate them. The only thing that works is momentum. Is because momentum is the real science. It's the real physics of the universe. The universe only cares in terms of understanding things that have energy. The only thing that matters is mass and motion. Where are you going? Velocity, mv. That's it. There's nothing more. Just like in electricity, it's just voltage and amperage, okay, which could be equated to velocity and mass. And there's no reason to think you square voltage to come up with your wattage, because you don't. It doesn't make any sense, and there's no need to do it. And there's no need to do it to this basic physics about energy in the universe. Energy is momentum. Force is momentum. Pressure is momentum. Weight is momentum. It's all just momentum. It's all just about masses moving, and when they interact with each other, they share, they compare each other's motion and divvy it up. It's just a currency. There's just this in the universe. There's this and there's this. There's this. You have all directions, but at any one time you have a certain amount of this and a certain amount of that. And if something impacts you that has this and it sticks to you, well, now you have more this and you're going to go that way. And if you give away something going this way, well, then obviously you're going to have extra going that way. That simple mechanics is the universe. It makes perfect sense. It fits all the evidence. I really shouldn't have to spend decades making these arguments. It's so bad on you. There's no defense for the fact that I have to make this argument over and over and over again, except you're belligerently stupid. You're trying hard to avoid accepting reality, but this reality is so hard and indestructible, and yet you're belligerently saying you have some logical reason to doubt that, yes, everything I just described here is absolutely true about how things in space work, and that there's no evidence of kinetic energy meaning anything. It doesn't have any relevance. And that's the absolute truth. And you're denying it because you're prejudiced against it, because you're a religious fanatic and you believe a fairy tale. And your wish for the fairy tale to be true is stronger than any desire you have to have integrity, which is pathetic. All right, so number 4. Have you ever seen a ballistic pendulum collect any more energy than just the momentum? So, it's just, it's plain question, and again, just a complete evasion. In the general lab setup, potential energy is stored in a spring and then released. So obviously the most famous way ballistic pendulums are used is with ballistics, that is bullets, not springs. But anyway, some of that is transferred to the ball, the bullet. You can calculate the launch velocity from the height reached by the pendulum. So again, that's not what they're calculating in the sense that you're basically saying how much energy was absorbed by the pendulum by measuring the pendulum's motion. And the only way you're going to get the right answer for the bullet is to calculate the momentum. So again, he's using the kinetic energy formula, which isn't conserved. So if you calculate the kinetic energy, you won't get the right answer for the bullet's actual momentum. It's mv. And then again, energy and momentum are not the same thing. So it's just nonsense that this is an argument about two descriptions of motion in the universe. And your silly claim, frankly, that one of them does something called work and the other one somehow doesn't, and you have it exactly backwards. The one that always does work is momentum, and the one that always fails to show up to do any work is kinetic energy. And that's the absolute fact. So again, have you ever seen a ballistic pendulum collect any more energy than just the momentum? So that's the simple argument, and I'll draw it again. All right, so just classic experiment. You take a very high velocity, so very small mass, big V, and you're going to collide it into a heavy object. Okay, so it's automatically got a very big M, and the fact is it's going to end up with a little v. And the fact is you'll always conserve the momentum in these experiments, like most of the momentum. At least 85+% of the momentum will actually get into the pendulum. And stuff, numbers like, for a bullet, for example, you can expect to lose 99.94% of the KE. So 99.94% of this KE number won't go into the pendulum. And you'll get some number that's something a little bit less than all of the momentum in every single example. So I've probably watched 20 different videos, and there's no evidence that any of them are going to be any different in terms of what actually happens when you actually do the experiment. And it's, again, decisive evidence that kinetic energy can't do work. This 2000 number isn't going to show up to do any work. It's not going to be able to collect it. Now, they'll claim there's 1999 joules of heat inside of the pendulum, but they never put a thermometer in there and prove any of that. And the simple argument is that you are a little short the momentum, so you can expect some heat is in the pendulum, but it's a small, minor amount. And the fact is the device is fairly efficient. Now, so we're arguing with all of mankind's technology, they can't find a way to collect this kinetic energy and make it actually do work. Not even a tiny bit of it. So nothing above the momentum. So you would expect the momentum to be conserved, and it is, generally speaking, and there's nothing above that. Never any evidence of even a little extra momentum. Because you can't make free momentum, is the simple argument. You can't put momentum in and get more momentum out of an experiment. You can't do it. And this is a classic example. And so the faster you make the particle move, the more you can expect to lose in trying to collect it. So again, they claim this does work. And there's no evidence it's doing any work. Anyway, it's not doing any. It's failing to do 99.94% of the capacity it has to do work, isn't showing up and doing any work. And again, most all of the momentum. The slower the projectile, the higher this number will go. And the faster it is, obviously you will generate some heat. Trying to catch fast things is never easy. But it's a clear example. I mean, it's a decisive piece of evidence. Okay, not one experiment where you collect a tiny bit more than the momentum, indicating a little bit more, like 2-3 joules instead of 2 joules. So you have 2 joules of momentum, and you end up with 2 joules or 1.9 coming out. They never get 2.2, ever. Not even a tiny amount. Not even 98.9, 96. Nothing. Instead of losing 99, collecting a little tiny bit more than that 0.06%. I mean, it's a shocking 0.06% is the only amount of kinetic energy that's being conserved. 0.09% of the kinetic energy is conserved. It's a ridiculously low number, indicating it's a ridiculous theory. It is not real energy because it can't be collected. It can't do any work. It can't move a spaceship. It can't move a ballistic pendulum. Again, there's no answer except your silly, crazy, fanatic religious kooks to think this isn't a hard, decisive piece of evidence indicating you're looking at the universe wrong. The experiments don't agree with your theory. Okay? They're pointing out how it's garbage and nonsense, and you're just pretending the evidence doesn't exist. That's all you're doing. Alright, question 5 and 6 are basically the same question, but I'll read them both. Have you ever seen a car going twice as fast do 4 times the damage? Now, I could have said a car going 5 times as fast doing 25 times the damage. Or a car going 3 times as fast doing 9 times the damage. Hugely out of whack nonsense numbers. And obviously the implication is that somehow their physics says it takes 25 times the fuel for you to go 5 times faster. So it takes 25 times the fuel to go 50 miles an hour versus 10 miles an hour. I think you all know that isn't true. All right, qualifying damage done is pretty tricky. So again, more evasion. It's pretty reliable, frankly. In a lot of cases, crushing something will tell you a lot. It's a way of measuring. What's your better way? Yeah, please, let me know what the better way to do it is. Here we might have fun discussing a discussion of the impulse momentum theorem. So there's no impulse momentum theorem. So whatever that is nonsense. Anyway, the maximum force will depend on the rate of change of velocity. So again, how fast the velocity changes can just depend on how you make the crushable substance. You can have it crushed for a long time or have it crushed for a very short amount of time. It all depends on how fast you can absorb the energy. There's lots of fast ways to do it. A big blob of clay. And that also depends on the initial velocity. So more nonsense. Of course, we're talking about an initial momentum. So the car has momentum when they crash into each other. It doesn't matter what anything called initial is. It's just what's its impact velocity and mass. And that's all you need to know. We measure, so again, just all evasion. We measure this in the lab with a video of a karate board break. So this is just more nonsense that this has something to do with karate board breaks, when again that's you're just measuring the breakability of a substance. So you're taking one piece of substance, a piece of wood, and saying this is how you can fracture it. This is how much energy it takes to break a piece of glass or something else. The board can flex about 2 centimeters before it breaks. Yeah, depending on the kind of wood it is, of course. If it brings a hand of mass m to a stop in 2 centimeters, we can estimate the force required. So all about this is how it's not about how much the hand weighs, it's about how much the arm weighs, of course, that it's all connected to, in the bones and the shoulder and your back and all the other rest of your body that's being also applied as energy. So again, it's just such bullshit to talk about the mass of your hand. Your hand isn't a hammer. If you double the velocity, the force required to stop it in the same distance quadruples. So this is you say so. And that would just be, again, just measuring the fracture, how something fractures isn't the subject. The fact that you can use different substances to make something look like it has more energy is, known. You can shoot a bullet into a million different substances and each one will shatter and fracture in a different way, and all he's arguing here is somehow the one that splatters the most means the bullet has more energy. No, it doesn't mean anything like that. So talking about the materials is just evading the subject. I mean, the simple subject was, do you see 4 times the energy being applied when you double the velocity? And the fact is you don't see 4 times the energy applied. And so I guess it's probably worth drawing some of this, but we'll relate it to the more explicit 5 times the velocity, 25 times the damage argument. All right, so a simple analogy, to this argument is the 16-pound ball going 8 and the 8-pound ball going 16. So bowling or something like that. And you're going to crash it into some mechanism that's going to collect the momentum from these objects by giving it to pins, for example. So in the bowling example, you're going to knock down pins. Now their claim is that the twice as fast ball, with half the mass, is somehow going to knock down twice as many pins. And the fact is that all it can exchange is its momentum. So they have exactly the same momentum. So they're going to give these pins exactly the same because they can only exchange their momentum. As the ballistic pendulum sort of proves, it works both ways. You can't. The 16-pound ball is going to hit the first pin, and what's it going to do? It's going to send it away at 8 velocity. Okay, so it's only going 8. It can't give it a faster velocity. It can only give it the velocity it has. So it's going to give it 8, times, let's say, the 3 of the mass of the pin, and the ball's going to lose exactly that much momentum. And the 8-pound ball going 16, it's going to give the first pin 16. So it's going to give the first pin twice as much momentum. All right. But later, okay, the 8-pound ball is going to quickly run out of energy, and the 16-pound ball is going to have plenty left over. So in the end, when you mix these two tracks, you'll see that they just curve over like this on each other. So yes, the 16-pound ball has an advantage in the beginning. The 8-pound ball, and the 16-pound ball has the advantage at the end. And the fact is, they're going to give away exactly the same momentum. So there'll be some pins going faster, but there won't be more mass moving. There won't be more atoms moving. They can only move the same amount of matter, the same amount of velocity, and that's all they can do. The same amount of mass, when you add up the MV, that's all there is. That's all it can exchange, and there's absolutely no evidence that this does twice the KE. Okay, there's no evidence there's twice the energy in the 8-pound ball, and the fact that no professional bowler goes anywhere near an 8-pound ball is a pretty good piece of evidence that, well, obviously there's not twice the energy in throwing the lighter ball, and there's no advantage, and there is an advantage to the steadiness and stability you get with a heavier ball. And also the fact that you're able to lift a 16-pound ball and stabilize it and gain a little bit extra from gravity. But anyway, so clearly no advantage to throwing the lighter ball. Clearly there's no experiment that shows kinetic energy being collected. So the Mythbusters did do the experiment. They did crash cars, okay, 2 identical cars. Crashed one at 50 miles an hour, crashed one at 100 miles an hour, and the car crashed exactly just twice as much. Drawn like this, I guess. That's it. 100 miles wasn't 4 times more crushing. Or twice as much. No, 4 times as much crushing. It's only twice as much crushing. It's twice the speed, twice the crush. No 4 times. Kinetic energy says 4 times. So again, it fails to show itself in another pretty good, hard piece of evidence. Totally ignored. Let's all just pretend all of that experimental evidence doesn't exist. To again prop up a fable, a silly story that should have never been invented. There's actually no logic to saying there's some velocity function that squares the capacity to move matter. All velocity does is create the ability to break things a little easier. Okay, so if I wanted to tip something over, if I throw 3 things at it really quickly, it'll tip over. If I throw the 3 things, one, and then I let it oscillate and find neutral, and then hit again and it'll oscillate, it won't tip over. So the fact is that 3 tennis balls worth of energy can look like more energy when it's delivered quickly, but it isn't more energy. It didn't actually do more work. It didn't cause more motion in the universe. It just caused motion you wanted to have happen versus motion you didn't want to have happen. The one you wanted to see versus the motion you didn't want to see. But it's the same amount. You can never change how much motion there is. You're just changing circumstantially. Okay, you can change something's circumstance. So if something's caught in a magnetic field and I want to defeat the magnetic field, if I move it quickly, then the magnetic field can only move at the speed of light. It has a limited ability to glue itself to these other things. If I can get it out of there quickly, I have to deal with very little force. If I try to move it slowly, well, then I'm really going to be glued. And so now we're back to the friction argument and how it's a lot more friction when things move slow than when things move fast. And so speed has an advantage in defeating friction, defeating force traps, defeating anything that's charge based or attached by some mechanism. You can defeat that attachment, that connection with velocity, okay, and cause an effect you can't create with slow motion. But that doesn't mean it has more energy. I mean, that's the real science. The real science is recognizing there's a difference between energy and circumstantial outcome. And so, yes, you can break a glass by hitting it with a higher frequency, hitting it quickly, concentrating all the energy in one place. There's tricks to applying energy that make it have an effect, but it doesn't mean it's more energy. I think a 12-year-old could understand that argument. So, one who hasn't been indoctrinated into the religion and the faith, they can understand the evolution argument. All right, as stated, the next question is pretty related, but we'll talk about it anyway. Have you ever seen a turbine spun 5 times as fast, produce 25 times the electricity? So it would be 25 times the electricity. Yeah, that's their theory. I'm saying, wait a minute, it's only 5. No, it's 25 times. So it's like a water wheel. If I made a water wheel go 5 times as fast, they're saying somehow it's going to do 25 times the work. Can't do it. It's only 5 times the momentum. It's only 5 times the capacity to do work. So he evades the whole question again. Conservation of mechanical energy into electrical energy depends on some other complex physics. No, it doesn't. If I set up a turbine and I don't spin it, it doesn't do anything. Okay, so all these magnetic laws and all the doesn't mean anything. It completely does convert motion into motion in another location. The conversion to electricity is you're just using it because it's convenient. But you're basically just saying, I spin something over here, I can spin something over there. And with the losses of the electrical transmission, I'll basically be able to conserve most of the energy. Most of this turning will turn into turning over here. But I can't make more turning. All right, and the simple truth is it works like anything else spun, so it's just a lie to imply you can't answer the question. Their theory says, okay, that I have done 25 times the work to spin it 5 times as fast, and I should be able to get 25 times the output energy. Okay, so he says it's not so much about the speed of the turbine. Of course it's about the speed of the turbine, as it is about the rate at which the energy is converted from one form to another. So it's just about the speed, frankly, and it's a pretty balanced equation. If I put a motor over here and a generator over here, I can turn the generator and the motor will spin proportional to how fast I'm spinning the generator. And so it's just bullshit to imply otherwise. But it's just an evasion of the basic conceptual point, which is their argument is that it takes 100 times the fuel to go from 10 miles an hour to 100 miles an hour. 100 times the energy. And that somehow you can expect to get 100 times the energy out. It's absolute nonsense. I can't believe I have to argue this. All right, so question 7. Do you think a one-mass cart going 5 velocity will win a tug of war? This is the part where I should have said 5 times. 5 times over against a 5-mass cart going 1 velocity. So you have 2 things with the same momentum that they're going to claim one of them has 5 times the capacity to do work. And yet again, you can't collect it. So in no experiment conducted is this ever found to be true, that the thing with 5 times the kinetic energy wins the tug of war, or in the case of the crash, moves the crash in its direction. So we have the crash experiments from Bruce Yerney, and they're decisive in showing that no, the thing with more, 4 or 5 times the energy, doesn't actually have any more capacity to show it has more energy. It can't defeat a much lesser energied block. So you have 2 blocks heading for each other, one with 5 times the energy, one with 1 unit of energy, and the 5 doesn't win. It's a tie. Indicating that obviously kinetic energy again fails to do work. No evidence that it has any power, any capacity to show that it has 5 times the capacity to do work, because it will not do the work. It will not do the work of moving the other object. Alright, so he evades this one with. Curiously, this has more to do with friction of the cart against the surface, so this is absolute nonsense. So he did some dopey experiment where he puts a bunch of oil on a table and then has a cart with slow moving wheels and a cart with faster moving wheels, and basically proves that higher speed wheels creates less friction, which is again my argument. And so it doesn't prove anything about the capacity to do work, because it's a deliberately made difficult to acquire friction surface, and it's just basically a demonstration of the fact that yes, friction is necessary for you to be able to move something on terrestrial land when gravity is creating the contact. The mass is important to creating more contact, and more contact means you can exchange your condition more readily. So obviously the more friction, the more exchange. The less friction, the less exchange. Increasing the mass increases the normal force and gives you more grip on the road. So you never increase any forces. And all you're basically saying is gravity has more effect, okay, the more mass you have. You collect more force from gravity if you're heavier. And that is an advantage in making you have contact. So if I blow a car, if I blow a feather falling, if I blow it against the surface, the harder I blow it, the more friction there is and the slower the feather falls. Right? The less wind, the less contact, the faster the feather falls. So you can understand it's not really about gravity, it's just whatever force is creating the friction, the stronger the force, the more force you have applying the contact, the more friction you have and the more exchange of the velocity, the more the feather moves the surface. Generally speaking, the heavy car wins. So again, this isn't about my question. So he just totally evaded. Do you think a 1 mass cart going 5 velocity will win a tug of war 5 times over against the 5 mass cart going 1 velocity? And just avoided the question entirely. There's nothing, this isn't about friction. This is that we could do this tug of war in space. You have an object going, a 5 mass going 1 velocity going this way, and you have a 5 mass going, you have a 5 mass going 1 velocity, you have a 1 mass going 5 velocity. You have the same momentum, but you have completely different kinetic energies. And the fact is the 2 will run out of rope and nothing else will move. They will reject each other, and the energy will just happen as a reflection for both of them, and there'll be no evidence that one of them had 5 times the energy. Alright, so generally speaking, the heavy card wins. Like I say, I did a video that's not on the subject. It's a greasy table with, showing how friction works, which is fine, because again, this is another argument people don't understand. They think friction is linear, that it doesn't matter how fast you're going, that it's always the same friction. When obviously, if you want to get across thin ice, you move quickly. And then you're applying less weight per second on the surface, per inch, sorry, not per unit of time, but per unit of distance. And obviously, you're less likely to fall through the ice, because per hunk of ice, you're applying less weight. All right. So those were simple enough questions, completely evaded. So I'll try to rephrase these. I mean, if somebody in the comments would like to phrase the questions more precisely to evade the evasions, that would be interesting, because, I'm not necessarily perfect at phrasing questions. But I have done it before. I mean, I have a bunch of questions also placed in the whatever you call it, the more description section on the videos, and they're not perfectly articulate either. So anyway, but yeah, the questions need to be answered. I mean, do you actually believe it takes 25 times the fuel to move something 5 times as fast, to spin it, or to move it 5 times as fast? And do you think that anything moving 5 times faster will do 25 times more work? Do you really believe that? And if you do, you're not believing it for any good reason. So another question I often asked Paul was, in at least 3 different places, why are you so confident? What experiment has you so convinced? I mean, right here, you're making my argument for me. You are conceding that a one mass drop 4 units of distance is is only in the gravity for 2 units of time and only collects 2 units of force. Your own statement verifies that a 4 pounds dropped 1 foot is not the same force as 1 pound dropped 4 feet. Not the same momentum, not the same capacity to do work. 1 pound going 2V isn't going to equal 4 pounds going 1V. It's not going to happen. It's not going to happen on a lever, that's for sure. Alright, so I have done my job once again, likely futile, but these are the teachers, so that's the important part of this video, is just pointing out that all of this bad science exists because of these bad teachers. They won't listen to arguments. They're belligerently, arrogant, patronizing, obnoxious, and they're also not good science. I mean, that's why they're teachers. It's because they're obeying those who can't teach rule. So they can't do any good science, and so they're applying themselves to be instructing people to be just as mentally disabled as they are, in terms of getting it all wrong, rather than getting the fundamentals as right as possible. And this energy is a fundamental. That's just, you get energy wrong about, in physics, you've gotten all 90% of physics is about energy. 95, I don't know. It's hard to imagine what part of physics doesn't have something to do with energy. It's what is the whole nature of interaction requires 2 things to move and to come into contact with each other, and then that contact is going to be an exchange of their condition, and their condition is their energy. So there's just no other way to look at it, that this is the most important subject in physics, and they don't care that it's got this ugly, idiotic duality stuck right in the middle of it. 2 silly different definitions of energy. Well, the silly prospect of an energy duality. Clearly, momentum isn't silly. It's worked. It always works. And if people were obedient to its conservation and understanding that energy just moves from object to object in the universe, it never stops, ever, 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 ever. It's always been somewhere before. It's a fundamental understanding. And they've ruined it. They've made very cloudy and dirty a clean piece of glass that people like Newton were looking through. Alright, till the next time, and such, and so forth and whatnot. Very disappointing. So, link is below in the description to these hundreds of exchanged arguments where all he did was evade every single argument made. Constantly just changed the subject. So anyway, I made the subject some stupid thing about some calculation that needs to be done. you know, somehow the concepts are calculations, when no, the concepts define the formulas you use to make calculations. And if your formulas are wrong, 1/2 mv squared, there's no point in calculating. So, till the next time, and such, and so forth, and whatnot. I hate it on this planet. Humans suck.